Good
yeah,
afternoon,
I just
sir.
need to swap my headphones. Wait lang, ah. All right. Can anyone hear me clearly, ba?
Yes, sir. Loud and clear.
Okay. Let's me Let me just share my screen. Okay. Hello everyone. Good afternoon. Sorry. Wait. There you go. Hello everyone again. I'm Edmund and currently I'm a 3D engineer at Skunk Works. And I've also been a volunteer here at GDG, currently the tech lead. And I've been engaged to quite some development in 3D, especially in games, AR, VR, and all of those 3D stuff. So I would like to start. Like if you're familiar with these titles here, these are the games that I've been playing but not engaged to. So I was hoping that in my career I might be able to somehow have an experience to develop AAA title games. But it made me realize that game engines are not I think game engines are just not made for games. It made me realize that it can be used for something else. So that's why I have explored quite a lot of fields, and yeah, it really does. Game engines are not only for games. So synthetic data sets in the field of AI or machine learning. A data set is somehow a collection of like data. It could be an image, audio, it could be numbers or text. These are being used to somehow teach a machine achieve a goal. So synthetic data sets, from the word synthetic. These are data that are not made by humans. These are data that are made by computers or through a algorithm or a specific program that addresses the issue of training machines um, on the collection of the data set itself or the data itself. So here is a 5 of synthetic data. Again, it doesn't exist in real life. So unlike a photo, it is being it's somehow been taken by a person or a photographer. So another it is not a replacement of real data yet. So with the technology today, well, if you carefully create a synthetic data, it could be a replacement to the real one. But for now, it's very challenging because with the technology of computer graphics and the availability of tools, they are only limited to those hardcore researchers. But now we are able to somehow have a glimpse on what synthetic data is. And first and foremost, it is very scalable. As long as you get the setup right, you could just leave a machine and click it, and it will generate like millions and millions of data sets according to your needs. But there are also has a downside. It is resource hungry because of course when we're speaking and generating images, it requires a beefier machine compared to a regular one. And of course, synthetic data is, I mentioned earlier, is algorithmically created. Mm, Sorry. Um, so it's algorithmically created, meaning it is done through code. So with that one, we can able to identify what synthetic data is with those 5 simple it's. So synthetic data, who uses it? Synthetic data actually is not new. It's actually old, but again, it was not accessible before to the masses. So the tools were not available yet. And synthetic data has been used by big companies like Microsoft. If you're familiar with HoloLens, they even used full synthetic data to make the technology of hand tracking and eye tracking with their HoloLens device accurate. So imagine that they're teaching a machine from using the data that was created by a machine. Another one is from Tesla. Pedestrian tracking, bicycle and vehicle detection, and car autonomy. They've integrated some synthetic data today. If you happen to watch their latest AI Day video, and it was very, very, amazing, because they were able to somehow improve their autonomous cars, and some of their like the technology behind like detecting the humans and differentiating it between the cars and the vehicles. It's very amazing that they've used synthetic data for that. Now, they have a quite a complex setup, and I haven't tried their method, but somehow we will get there soon. And of course, if you're familiar with Amazon Go, their cashierless store, they happen to use also synthetic data for product detection as well as tracking human behaviors. So for anyone who's not familiar with Amazon Go, it's a small concept store by Amazon in which you just need to somehow use your phone on the entrance para mag-login ka dun. Then after that, you just pick everything from the shelf, and it will be automatically deducted by your account. So no one will interfere. Any cashier, no cashier can be found there. So that was an amazing concept by Amazon, and it happens that they were using synthetic data sets as well. And of course, here at Skunk Works, we're using synthetic data to somehow improve our post detection, our product detection, and of course, human tracking. We have a motion capture suit on our office, so we can somehow curate a 3D model to act what it really needs to act. So how to start? Like if you're an average guy, or like you want to learn how to create synthetic data, there are a lot of ways to do that. But synthetic data somehow needs a little bit of technical background, because it involves computer graphics, it involves coding, of course, and it involves problem solving as well. So the process of creating synthetic data starts at identifying what kind of data to prepare. So if you have a problem, let's say you want to detect a soda can. So you need to coordinate with your the other AI engineers and what what are datas they're going to need. So once that is defined, we need to set up the simulation environment as well as prepare the assets required. Now, these assets could be images, 3D models, this could be textures, anything. And in setting up the simulation environment, this could be a 3D world. Then it could be a room, it could be an environment, let's say a landscape, it could be anything. And that includes how the simulation works, because when creating synthetic data, it revolves around a simulation, and we will further explain that as we progress to this talk. And once we set up the environment and everything is okay and the assets are already integrated to that environment, then we need to generate a few samples for validity. So when we say validity, before we proceed to generating millions and millions of data sets, we need to test out if our data being generated are okay with the AI engineers. So we need to validate that, and if it fails, then we need to go back to setting up the simulation environment again, and we need to re-prepare our assets if we need to change something about it. But once we somehow pass the few samples, then we need to proceed to generating full amount of samples. So this could be like millions, or it could be as little as hundreds or a few thousands of data sets, depending on what you need. This is also defined on identifying what the data to prepare. That's part in how much data are we going to generate. Then once the full samples are already generated, this can then be used to train our models. So you're familiar with these tools. I know some of you are familiar with these tools because some of the games are made using with these tools, and most of them are free. Unity is free, Unreal is already free, as well as Blender. Now these tools are more on the 3D computer graphics technology. Unity and Unreal are game engines, and Blender and Maya are 3D modeling and rendering softwares. And of course, NVIDIA, the well-known graphics provider, they also have tools available to assist us in generating synthetic data. But most of these tools are very accessible, and you can start generating synthetic data with this few selected tools. But now, for this session, we're going to focus on Unity because that's the field where I have more experience with. And they have this tool, what they call Unity Perception Tools. Now, Unity Perception Tools is a package which can be added to any Unity project, and it can provide semantic segmentation data sets, instance segmentation data sets, as well as bounding boxes for 2D and 3D data sets. So the cycle of Unity perception, they have this concept of a scenario. A scenario will contain a seed, a instance count, and instance index, but we will be focusing more on the seed. The seed is a unique series of numbers which will be used for the simulation to create a not so random iterations. So somehow it has a concept of randomness, but it is based on a seed. So anytime that you will start to generate the synthetic data, if you put the same seed, it will somehow randomize accordingly to what that seed is. So each scenario will have a number of iterations and the frames per iteration. The number of iteration is the number of cycles in which the scenario will change its parameters, or the simulation will change its parameters. Then the frames per iteration is how many frames should I render based on these parameters. So each frame per iteration, each frame being rendered, they are somehow followed by a randomizer. So it could be a randomized position, it could be a randomized texture, it could be a randomized lighting to create this diversity of synthetic data. So not just static lighting, but more creating more diverse, so that our model soon to be trained must be able to somehow predict depending on the different environment, because in real life we have like a very diverse environment all around us. So once that randomizer sets the scene, it will then contact the perception camera, which is a component, and tells them to capture that image and fully label and annotate those images. So that's the whole cycle. until such time that the number of iterations is achieved, then the cycle ends and you will have this synthetic datasets batch. So we need to set up our simulation environment. So we'll get started on this one. So the first thing you need to do, I assume that we're familiar with Unity. If you happen to have no idea what Unity is, then you can download it for free, play around with it, and everything that we will do here can be done with the free version of Unity. So the first thing we need to do is create an empty scene. Next thing is we need to import our perception tools package. So we just need to open the window of package manager, and we just need to add a package from a git URL. You could type com.unity perception, and it will automatically download the necessary dependencies according to that repository. So we can confirm if our perception tool package has already been integrated to our project if we check our project tab and as well as our package manager. And by the way, perception tool is still on a preview state, so it is not advisable to go full production in this one, but more on an experimental and research state. So after that one, we have integrated, we downloaded all the libraries required for Unity Perception to run. We need to create another empty game object. Then after that one, we need to add the scenario. So earlier we've mentioned what a scenario is. So this is how it will look like on the game engine. So you need to add it as a component to a game object. So right now, we have a fixed length scenario. Fixed length scenario will be bounded dun sa iteration, number of iterations and number of frames natin. So this is what it looks like, a fixed length scenario, the component we just added to a game object. So again, it has a random seed, total iterations, the instance count, and the instance index. The purpose for this one is you could build the simulation and you can upload it to the cloud, and you can generate the synthetic data there sa cloud services nila. So you can have like multiple instances of this simulation to even further increase the scale of your synthetic data. So the next thing we need to do on a default scene with Unity, we need to attach our perception camera component. So we could do that by selecting the default camera in Unity and just add a component called perception camera. So perception camera, this contains a few simple parameters, but we need to focus more on the camera labelers. Camera labelers, these are the somehow annotators for the simulation. So right now, Unity provides this selection. We have bounding box 3D, we have a bounding box 2D, instance segmentation, key point labeler, object count labeler, rendered object info, and the semantic segmentation. Key point labelers are being used for poses. So if you want to create synthetic data with that involves humans, then key points are the right thing to do. But for now, we'll be using our bounding box to the labeler, because later on I will show you something amazing with this simple labeler. Excuse me. So now preparing the subject. So let's say you've finished setting up the environment. Actually, that was the few steps. That was the only few steps needed to set up your simulation environment. Then once you're done with that, we need to prepare the subjects as well. Now the subjects are the assets. So I've downloaded this 3D models by Anthony Yanez from Sketchfab. These are just simple simple soda cans. So we need to import that on our project. So after that one, we need to prepare those products or the subjects. So when you import a model, you can drag it on the scene. So after that, we drag it to the scene. We need to click the game object, and we need to add some few components as well for Unity simulation to work. And first is we need to add a labeling component. And for the sake of randomization, we need to add a default rotation randomizer tag. Labeling component is the one indicating on what the annotation name would be for this object. So later on, you will see how this works. So after that, once we prepare our subjects, we need to create them as prefabs. So prefabs, if you're not familiar with prefabs, it's a term in Unity that a game object, once you set it up, once you set up everything for it, you can just create a somehow an instance of it, so that every time you brought it back to the scene, it will contain all the setup you made for that game object. So we need that one because later on we will be using a foreground generator in which it will need some prefabs to place the products in your scene. Then once we have that, we need to somehow create a ID label config. And this is somehow a reference, a lookup reference for our perception camera. This will be used to indicate what the camera sees and what it needs to label. So before, we've set up our products containing a label according to their names. So on our ID label config, we need to somehow add that also. So this is just a list of what are the expected products or subjects that the camera will see. So later on, this will somehow fall into places para ma-connect natin yung ma-connect natin yung process na pag-annotate ni Unity Perception. So with that, once we added our list of our products or the subjects, we need to add it back to our perception camera component. So this will be used by our bounding box labeler on what product will it need to be, what product should it label. So makikita natin yan dito once we hit play and once we set up our subjects. If there's a box that will somehow, the yellow box that will wrap around your object, then that means that the labeler is working and it's able to detect those subjects, and those subjects will have the annotation data as well. So, but with this setup, it's kind of it looks static. So we need to add some randomizers to create those diversity of synthetic data. So we need to add some finishing touches. We set up our simulation environment. We have set up our products or the subjects. Now we just need to add some little bit of finishing touches just to make our simulation somehow generate a proper, it's not proper, but usable data set. So remember earlier we add a randomizer, a rotation randomizer tag that will tell the scenario component that any objects that has the randomizer tag will be somehow collected, and a rotation randomizer script will run on top of that game objects that has a tag in it. So in a scenario, we can add a couple of randomizers, and these are done in sequence. So if you have multiple randomizers, the first randomizer to be executed will be on the topmost. So you need to be careful on the sequence of your randomizers. Later on, it will be showcased and it will be showcased why it is very important. So we added our rotation randomizer. Now we just need to tell our scenario that we have a few products, like few products or subjects that we would like you to randomize the placement around the scene. So lately we created a soda can for Coke, Mountain Dew, Pepsi, and Sprite, and those are the prefabs. So that's the reason why we converted our game objects to prefabs, so that the scenario can create multiple instances of those prefabs accordingly. Then we somehow set up the placement area and the separation distance just to make those soda cans somehow uniformly arranged on the scene. So once we set those up, it will somehow look like this when we play it. Okay, it appears to be working, but we need to somehow fix something. We noticed on our simulation that the cans are not rotating randomly, they're just standing. And I think they're too close to each other, and it's not a good quality data set. So simply drag our foreground placement randomizer above our rotation randomizer. So with that one, the sequence would be, okay, scenario, we need to generate multiple soda cans. And after that, we need to randomize its rotation. So that's how the sequencing plays an important role for our randomizers in our scenarios. So we also adjusted some parameters, the placement area, and as well as the distance between each can, or each subject rather. So let's test it out again. And this looks promising. This could be usable. We somehow generated our first synthetic data. This can be somehow used by an AI engineer to train some of their models. So now we created those few samples. So the first sample was created with only 100. Now we can increase our total iterations if we validate those previous samples. Now it's okay. Let's have a go signal. Let's generate, say, 100,000 of that one. So we just need to change this. We just need to change this parameter here. So let's say 1,000 samples for randomly placed scans, an image with randomly placed scans with full pixel perfect annotations. So just click play, and all we have to do is wait. So everything will be handled by Unity simulation. After the simulation is done, it will stop by itself, and you will have your data set. You can go click your camera component, perception camera, show your folder, and it will contain all the all the images being created. And as you can see, it gives us pretty much a random looking image with different soda cans. But yeah, for me, we can somehow improve this one. But for the sake of this talk, everything will be contained on that folder. We have the images and the annotations. So it would be the annotations would be on a JSON format. So it's pretty much easy to read. So these are the sample of images we made. The time it took to create me this image or data sets didn't take me 30 minutes. So imagine if we compare that into a real life scenario. Let's say you were instructed by your boss, um, okay, I need pictures of a soda can with different angles or different perspective of camera. Now, compare that to when creating a synthetic data. You could just somehow set up the environment according to the requirements, and you will have lots and lots of images complete with annotations with a minimal time needed. So, yeah, there are some issues with making simulations. If you don't curate it properly, like for example, this one, this doesn't exist in real life, right? Well, unless you forcefully like will two soda cans together, it is. But for the randomization or the average happenings in our life, it's very virtually impossible. You could see this kind of um can or see this kind of image or I don't know scenario. So that's why synthetic data has its own downside. This could potentially ruin your model. So you need to somehow carefully curate our scenario. So if we somehow dig deeper, we can create our custom randomizers. We could create our custom scenario flows. So yeah, pretty much that's how the synthetic data cycle works. Now we can also validate our generated data. Now imagine if you say a million and you want to know if how many are Pepsi, how many are Coke, then you wouldn't do it manually. So we can use Docker for that one. We just need to run some few commands, and it will somehow provide us insights on what data sets, the statistical side of data sets are. So for now, since we use our bounding boxes, we try to look on our bounding boxes data. So this is different from within the game because um, this statistic data, these are the annotations created by our simulation. So those are not pre-configured but read, meaning they were digested by the notebook and interpreted those coordinates accordingly to the image. Now, with that one, I would like to share to you an experiment, what I did on a sardine can using synthetic data. So, of course, we need to prepare the object, the reference object. We created a 3D model with the proper measurement, of course, because that would somehow affect our model later on. So, jump into Blender. I created this replica, a 3D replica of a sardine can. After that, of course, we set up the simulation and generate the synthetic data. And I just leave it there for, I think, 1,000 samples. And in order for me to interpret this into a YOLO 5 model, I used RoboFlow to convert those data, and as well as Google Colab to run a training for a model. And it surprises me that after the training, like for a few samples, like 1,000 samples, it was enough to somehow detect a real life sardine can. So imagine that I've never showed an AI or a model that what a real sardine can is, but somehow it was able to assume out of those synthetic data that this is a mega sardine can. And that would be the end of my talk. And thank you so much for having your Saturdays with me. And if you're curious about synthetic data, you could email me at my email, of course, edmundmilcx.com, or you could link up with me at LinkedIn. Or if you would like to know more about what we do, you could follow Skunk Works AI at Facebook. So thank you so much, guys.